All right, on to polar coordinates. So this is a little more recent. Hopefully it's a little more fresh in your mind. We have rectangular coordinates and we want to find the polar coordinates. So we're starting out with x and y. And our goal is r theta. So our process for this is 2 steps. First, we're going to find r using square root of x squared plus y squared, just Pythagorean theorem, and that is on your equation sheet. And then we're going to find theta by doing tangent of theta is y over x and evaluating the quadrant. That keeps looking at the quadrant of your original point, keeps you from having to mess around with the plus 180 when x is less than. So you don't have to worry about that if you take the quadrant into account. So for this problem, r is square root of -3 squared plus 5 squared. And that is 9 plus 25. So that is square root of 34. And then here, tangent. Here our y is 5 and our x is -3. We are going to need to use our calculators on this one, so I'm going to pull that up. And then make sure I'm in degrees. I don't particularly want radians right now. And you got practice with this when we were in the vector. And from like a week ago, my calculator is still freaking out about that polar coordinates problem. So I'll go ahead and do it on a handheld calculator and just help walk you through what I'm doing. So I'm going to do arctan of 5 divided by -3. Now the calculator doesn't particularly care where that negative is. It's going to treat that negative the same whether you put it on the top of the fraction or the bottom. So don't think that it knows what you're doing. Again, I'm making sure I'm in degrees. And when I do arctan here, so in my calculator, I just did tan to the negative first of 5 over -3, and I got -59.036 degrees. So think about what quadrant our original point is in. So our original point is at -3,5, so it'd be over 3 this way and up 5. So our original point is in quadrant 2. So how does -59.036 transfer over to quadrant 2? Well, -59.036, what it's giving us is this angle down here in the fourth quadrant, that negative acute angle. That actually, if we add 180 to it, like it says on our equation sheet, will transfer over to quadrant 2 for us. To get that over to quadrant 2. So what we're getting is the reference angle, the distance from the x-axis. That's what our calculator is giving us, luckily. And it knows that if we add, we just need to know the rule to add 150 degrees. So if you get an ordered pair that doesn't give you a unit circle value, that's your game. Use your equation sheet, work carefully, make sure that your answer is in the quadrant that you expected. So when I add 180, I get 120.8 39.64. All right, a little more. Give the exact value of the rectangular coordinates of the point if the polar coordinates are -6, 11 pi over 6. So going from rectangular to polar, I think, is a little harder because of that theta situation. Going from polar to rectangular is very straightforward. Use this. X equals r cosine theta. Y equals r sine theta. And we're given r and theta if we're given a polar coordinates point. So here, -6 times cosine of 11 pi over 6. Cosine of 11 pi over 6 is radical 3 over 2. 6 divided by 2 is 3. So there's your x value, -3 radical 3. R sine of theta, so again, our r is -6. Our theta is 11 pi over 6. And sine of 11 pi over 6 is -1/2. -1/2 times 6 is +3. So there's your ordered pair, negative radical 3, 3. You do want to make sure that this makes sense. So when I think about how 11 pi over 6 to -6 would graph, I would go to the 11 pi over 6 angle, and then the -6 as the r takes me away from it. So my point is going to end up in quadrant 2. -3 radical 3, 3 is going to be negative in the x direction, positive in the y direction. So having a quadrant 2 xy matches having an r theta that is a negative r and a quadrant 4. All right, hopefully that was helpful. I'm sorry that my my graphing calculator is not functioning at this moment. Try to get it working here. The next problem, we have a little bit more polar coordinates before we get to vectors. That'll be on the next video.